Cool. Wait, I can't remember if we did this before, but there's a little note above it anyway. So for part A, do you remember how you would do it to get X? I think we just touched on it at the end. So we started talking about how if I have 7x equals 12, then x equals 12 over 7. If I have sine x equals 0 0.7, then x equals inverse sine 0 0.7. So anything in maths to move something around, you do the inverse, right?
Yeah.
So does that remind you what the inverse is of a log? So for question A, you've got log base 3 of x equals 1.8. So what's the inverse of a log 3?
Um,
The inverse is always the base, like raising both sides to the base. Mm.
oh, okay.
So if you do that, you're going to be left with x, and the right-hand side will become 3 to the power of 1.8. So we've raised both sides to 3 to the power of. Okay,
Okay.
perfect. So then in that case, yeah, what would be the answer for part B? What would you raise both sides to?
5 to the power of minus 0.3.
Good. So x equals 5 to the power of minus 0.3. Well done. And then for part C, how would you get x minus 3? How would you get rid of that log 8?
You do 8 to the power of 2.1.
Good. And then, of course, to actually get x, you're just going to add 3. Yeah,
Yeah.
perfect. Um, could you try D, E, and F by yourself? And then we'll go through the answers together.
Okay.
Um, let's go through them. So I'll go through the first one. You can just check if you've done it correctly. So for D, to get rid of the log with a base 4, we raise both sides to a power of 4. Um, so on the left-hand side, we're left with a half x plus 1. On the right-hand side, we get 4 to the power of 3.2. Um, we'll understand why that's the case later on as well or even if you remember how the graphs work for log and exponentials. But for these kind of questions, I would just memorize that the inverse of a log is um, whatever the base is. Um, then x equals 4 to the power of 3.2. Take away 1 and divide by half, which means that x equals
166.
0.9 or 167 if it's three significant figures, yeah. Okay, good. And then for E, what would you do? Do you want to talk me through that one?
I moved 15 to the other side.
Cool.
And then after I did that, I did 3y equals 2 to the power of 5.3.
Good. And we can get rid of the minuses as well and then do what you said. So 3y equals 2 to the power of 5.3. And then just divide your answer by 3. Good. Well done.
And I got 13.1.
Perfect. Last one. So for F, what would you do?
I moved 4.2 to the other side
Good.
and I got minus 0.6.
Good.
And then I wrote down the equation 1 minus 5t equals 6 to the power of minus 0.6.
Good. And then you can take away the 1 and divide by -5. So
Yeah,
well done. And do you understand why we do all the steps?
yeah,
Perfect. Uh, did you get 0.132?
yeah.
Okay, well done. Cool. So these are like one-step log equations. So now we have the proper log equations. I'll show you how to do them. So we've done this rule before. Um, I guess you could call log2 3 and log2 x like terms. How could you collect those two like terms based on one of the log rules we learned before uh, this, like a while back? How would you collect the two of the logs together?
Um,
Do you,
they have the same base, I believe.
yeah, they have the same base, so how can you turn it into one log instead of two?
You multiply them.
Good. So for part A, instead of log2 3 plus log2 x equals 2, we'd write log2 3x equals 2. So now it's two steps. So that was the first step. And the second step is just as what we did before. So 2 to the power 2. So x equals 4 over 3. Does that make sense?
Yeah.
Cool. I'll do B with you as well. So for part B, we're going to combine them again. So what would you get when you combine the two like terms? So they have the same base, but this time they're being subtracted. So how would you collect them?
You would divide it, so it'd be log 6, 12 over x.
Good. Equals 3. And now it's the same as what we did in the previous question. So 12 over x equals 6 to the power 3. And then you can carry on and rearrange that however you need to. Does that make sense?
Yeah.
And do you get what I did in this step? There's
You
a
flip
different ways to do that.
fraction.
Sorry. So you can obviously do it that in different ways. You can times by x if you want, but I just flip both sides upside down. It's nice and quick. So if you just have two terms, you can do that as well.
Okay.
Okay, cool. Part C, let's do that together. Um, so first of all, the like terms aren't on the same side, if that makes sense, because 1 and log 5, 6 are not like terms. Does that make sense?
Yeah.
So let's take the logs on one side and non-log terms on another side. So 2 log 5x minus log 5, 6 equals 1. Now, can I combine them?
Yes.
I can, but not yet, because there's a 2 in the front of the log 5x. So therefore I can't apply the rule yet. So what would I do with the 2?
I'm not sure.
Again, go back to the rules we did like a couple of weeks ago or a week ago. How would you um do you remember what the rule was about a coefficient, like 2?
Or would it go as a power of x?
Yes, spot on. So what would it say? Log 5.
Log 5x squared.
Good. And now you can combine them. So you get log 5 x squared over 6 equals 1. And then you can do the same steps from the previous question. X squared over 6 equals, what would it be?
5 to the power of 1.
Perfect. So therefore x squared equals 30. So x equals square root of 30. Yeah,
Yeah.
cool. It would be plus or minus, but um you can't have negative logs, so it's actually just going to be the plus version. Cool. Do you want to try D by yourself?
Okay.
So I'll keep that on the board so you can use it to help you. It's quite similar. Okay, cool. Talk me through the first step then.
I divided both sides by 2.
Okay, that works. So what did you get when did you get log 9 x plus 1 equals log 9 2x minus 3 plus?
0.5.
Okay, good. That works. That gets rid of the 2. Because you've already done it that way, just for practice, let's do it without dividing by 2. If you didn't want to divide by 2, what would you do instead?
You'd use the power rule.
Perfect. Good. So you get your 2's going up and you get log 9 x plus 1 squared equals log 9 2x minus 3 squared plus 1. And then what would you do next?
You would rewrite the second part. Oh,
Um,
wait, no.
so
Um,
if you had a year, like an equation in year 9, like 7x equals 5x plus 1, what would you do?
you would move the x to the same side.
Yeah, so that's called collecting like terms, right? And I purposely broke it down in that way. So when you're doing these kind of things, think of it as the same. So you always want to try and collect like terms, okay?
Okay.
So all logs on one side, all non-logs on another side. So log 9, x plus 1 squared minus log 9, 2x minus 3 squared equals 1. And then what? We can still collect like terms further, combining them into 1. So how would you do that?
But you would divide it.
Hmm. Cool. And then you know what to do from there. You're gonna raise the other side to write 9 to the power of 1, and you're gonna get a big quadratic. Okay,
Okay.
cool. Let's move on now to a few more questions, which are very similar, but there may be a few small differences. So the reason for the differences is if you take something like question A, every single term is a log term, whereas if you take something like question B, there's logs on one side, not logs on the other side. Okay. So I want you to be careful about the difference between the two. So if you take B, you already know how to do a question like B because we've just been doing that. So can you just talk me through part B first? Hello?
Um,
So you've got logs on one side, non-logs on the other side. Can you collect the two terms together?
yeah.
Go on. How would you put them into one?
You would multiply them together.
Yep. So what would you get? Log 9.
10 times x.
Yep. So 10x equals 3 over 2. And then what would you do as your next step?
You'd raise the other side, so you'd get 10x equals 9 to the power of 3 over 2.
Perfect. And then x equals 2.7. Yeah.
Yeah.
So questions like B, you know how to do. Questions like A, you don't know how to do, but they're actually easier. So now watch how I do part A. Because everything is a log, it doesn't matter what's on the left, what's on the right. So let's just combine what's on the left. So I get log 3. What would I get? Log 3
5x.
Yeah, equals log 3, 2x plus 3. Now, let's say if I had, actually, instead of that, like, if you have log 5x equals log of 2x plus 3, then surely it's true that 5x equals 2x plus 3, right? You can
Yeah.
just cancel the logs, done. So it's even easier. So 3x equals 3, x equals 1. That's it. Okay.
Okay.
So now when you do it, you're going to notice question C, log, 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 and a half. Question D, log, 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 log. So watch the difference between C and D when you try them. Okay,
Okay.
cool. So D should be the easier one. C should be the weirder one. But both of them are very similar. So I'll keep the examples. Try C and D. Okay. Which one was the easier one? Was it D or were they both the same?
I think D was easier.
Cool. Let's talk through D first. Do you want to tell me what steps you did?
First I combined the logs on both sides.
Cool. Like that.
I didn't write it like that, but
But
like
basically
I
the
got the
same
whole
thing.
part. Yeah.
Perfect. So yeah. Oh wait, no, I've done the first one wrong, haven't I? What mistake did I make? Actually I got them both wrong because I didn't I times them by accident. What should I have done? I didn't read it properly.
Well, I wrote 5x over x plus 2 equals log 5, x plus 6 over x.
Yeah, that's better. Good.
And then I took the logs and then I cross multiplied.
Perfect. Then 5x squared equals x plus 6, x plus 2. And that's pretty normal for questions to end up like a quadratic. So you'd finish solving them and you'd get your two answers. And the question will usually prompt you anyway, but for example, in these, because it's just directly a log, the answer can't be negative. So if you have two answers, you can get rid of your negative one. Okay,
Okay.
cool. We still have 2 minutes, so we can go through on the call, so we can go through C. So what would you do first, like before you do the combining and all that?
Rewrite a half as a log.
How would you do that?
And because 4 to the power of a half is 2, then you can write a half as log 4 too.
Okay, that's all right. Did you like know that from, did you already know that from before?
Yeah.
Oh, okay. That would have been quite hard for me, so I'll show you what I would do. But if you're able to spot that, that's perfect. If you think back to the other one, there's another method where you just take all the logs on one side. Yeah. Okay.
Okay.
So you have logs on one side, non-log terms on the other side. So then you don't have to worry about it. But what you knew made it easier. But in this case, I would just do this. A good question here is how would you combine them on the left-hand side? What would you get if you put them into one?
Um, x over, no, x minus, we know x over x minus 1 minus 3.
Times 3.
Oh,
Yeah. Because, hey, can you hear me?
yeah.
So, this is really important. So, obviously, you'll have your x to start with, and you know that whenever you minus something, you're going to divide. So, you're going to divide by x minus 1. But then the 3, what about the 3? Well, just think of it this way. Think of it as anything that's a plus, you can keep it at the top. Anything that's a minus, you can divide by it. all in one go. So I can have x over 3x minus 1. Does that make sense?
Yeah.
Cool. And then you have x over 3x minus 3 equals 4 to the power of a half, which is just 2 anyway. And then you can carry on and solve that. Okay. So just to practice that method one more time, and then we're done. Let's do e together. Actually, e is all right because okay, we'll do e and f together just so that we're completely happy with solving equations. So talk me through e. What's the first thing that looks weird that we want to fix or tidy up?
Um, like the left side,
Yeah, what about it?
the two in the front.
Good. So log 6 x squared. Okay, done. That's one thing out of the way. Well done. What's the next thing we can fix or tidy up?
And put all of the logs on one side.
We can do, but both sides are logs anyway, so we don't have to do that, if that makes sense.
Oh, okay.
So we can just tidy up the right-hand side and yeah, literally just tidy up. How would you tidy up the right-hand side using one of the rules?
And combine the logs of combine the logs on the right side.
Mm-hmm. What would I write when I
10x minus 25.
10x minus 5, yeah. Good. Yeah,
Yeah.
cool. And then next step?
You drop the logs.
Perfect. And then it's a quadratic because it's the next square. You can equate everything to 0 and solve that quadratic. Okay,
Okay.
perfect. Last one then, and that's everything about solving equations with logs. So f, um, you have a log term, you have another log term, and you have a non-log term. And you can do your method of using like a log 7 thingy, but let's try not to use that method. Um, do you know what it would be to get one anyway?
Wait, sorry, repeat your question.
If you're using your method, what would you write in place of the one?
I don't know, I just knew it for that specific question.
Oh, okay, good. So that's why we don't want to use it because it's a little bit fluky. Although
Yeah.
you do need to know that log a is always one, but your calculator will tell you that anyway. So you could actually change one. So based on that, what would you change one to? Log
Log 7, 7.
exactly. So we can do that, but I want to avoid that method just because it's hard to remember under pressure. So let's stick to our proper method. Uh, I want to solve it as if it's a year 9 question. I want to collect like terms properly. So how would I do that?
Would you move it to the other side?
Yeah. So what would it look like?
Log 7, 4x minus log 7, 1 over x minus 6 equals 1.
Yeah. And then next step?
Or would you rewrite log 7, 4x?
Yeah. Like both of them into one. How would you do that?
4x over 1, uh, yeah, 1 over x minus 6.
Okay, good. And then how would you get rid of the log 7 thing?
You'd raise the other side, so it would be 7 to the power of 1.
Good. And then you can times that back to the right and it'll make more sense. And those kind of things you have to practice and try. Worst case, if you have a stacked fraction, A over B over C, right?
Yeah.
It's the same as having A over 1 over B over C. So you can think of GCSE. How do you divide fractions in GCSE? Like, what's that KCF thing?
Keep change.
Yeah, keep change flip. So it'll be A over 1. Divide, instead of divide, you'll have times C over B. Yeah. So in this case, if you did want to tidy it up, 4x over 1, you'd get 4x over 1 times x minus 6 over 1 equals 7. If you wanted to do it like that. Okay. And
Okay.
I actually never thought your method is actually much easier, the log 7 thing, but it's just in case you can't identify it or if it's a weird number. Okay,
Yeah.
perfect. That's everything for solving logs, so it's a good place to stop. Um, I think for you, best thing to do is just get really good at solving log equations because it covers all the rules. Once you're comfortable with that, we can look at a few of the modeling questions another time, but we can just move on to another topic for now. But I think if you're good at solving equations, you've got the gist of most of logs.
Okay.
Cool. Um, okay, have a good evening. I'll see you later.
Okay, thank you. Bye.